problem? How is this a challenging problem? What are the existing solutions for the problem? And if there are existing solutions, why are they not sufficient? What is the weakness or the limitation of that particular one? If you're able to write all these things or visualize all these things, then you can start the project. If you have still doubt in any one of the aspect, then again, you should do the literature survey and you should make it clear before starting the problem. Next one is, you should be able to visualize two things. One is, if I apply this particular method to this particular problem, whether it will work or not. Without visualizing that, you cannot apply everything, right? You should have an intuition, what method or what algorithm or what architecture or what framework should I apply for a particular problem. That you should know. That you will get by doing the literature survey itself. Then you should be able to define how it is different, novel, or better. This visualization should also happen before you start the project. So if it is completely novel, so this is a fictional character, Baymax, which is a personal assistant, which is as equivalent to human. So this is extremely novel. It's there in only, it's a fictional character, as I said, but it's not so far from reality. People are doing it. They are in the entire robotics field. They are going about the low-cost personal assistants and all. So it's a very novel problem. So you can also try with that. So if it's a very novel problem, how to do the methodology and results, that again I will discuss in the coming slides in the case studies. The next is doing problem statement and objectives. That is defining the problem statement and objectives. Coming to the problem statement, this is one of the way. It's not the standard way. Generally, a good problem statement will have the following details. One is, what is the solution which you want to give, and what is the problem, that is P, and solution is, desired solution is D, and from which subset or set which belongs to domain S you are taking that particular problem, and what technique or the method which you are using to solve that particular problem. So this is one of the template or the format in which you can write a problem statement. There are so many ways, again, as I said. So this is one of the way. Generally these, but the components, all these components will be there in the each problem statement. Then what is objective? What is the difference between problem statement and objective? A problem statement is a bit generalized way. So where you will tell like deep learning techniques I will use. So that is the technique name. Why? Because if you specify use cascaded CNN for that, and if you don't get results at the end, you need to change the problem statement. So generally we make it problem statement a bit more abstract level or a bit more easy. I mean, it will be of generalized, a bit more generalized when compared to the objectives. But in the objectives, we will clearly define. So what is objective is, the entire problem statement can be solved using some 3 or 4 procedures if you divide into 4 sets. So all those 4 sets we will write in the objective. Generally 2 to 5 objectives are observed for each problem statement. Now coming to the objectives are always precise. So because you can change the objective also. Say for you can clearly tell for this particular data, I am using this particular method for this domain. You can clearly tell what are the things. And if you are doing pre-processing, you can mention there. If you are doing any classification, you can mention clearly there, or localization, you can clearly mention there. So objectives should be always clear and specific. Don't generalize the objectives, because if you generalize the objectives, then your project will not end. So objectives should always be specific. Then generally, often the keywords which we use for objectives is to design, to develop, to collect, to construct. So all those things generally we use. But the one thing we should remember is we don't generally use the term like to understand the basic or to compare the results. So all those things are not objective. They are part of the project, and that is true, but they are not the sole objectives. In some cases, only in few very rare cases where we use comparison as an objective. Rest, actually, all these things are generally not used as an objective. That you should remember. The next thing is methodology. So coming to the methodology, for computer science, I will just specify. In methodology, you should be clear what exactly are you going to do in the project. Say, for example, you can design a method which is very clear and which has a systematic number of steps and everything. You can you can even design the system design or algorithm or pseudocode. So till here, generally, this is a Chomsky hierarchy. So Chomsky hierarchy, if finite automata is already done to the student, then they will know. In the Chomsky hierarchy, we can see from regular languages to P or NP class, all the things we can write an algorithm. We can run in a Turing machine, deterministic or non-deterministic Turing machine, and we can see the result. So for any problem where we can write where we can find a solution in the P or deterministic or non-deterministic Turing machine, that's for all those problems we can write an algorithm. So the one which is beyond NP class, that is this P space, NP space, or exponential time, space, decidable, undecidable, acceptable, trackable, all those problems, they come under NP hard. Here you can see. Even for NP complete problem, we can write an algorithm a bit, and you can add a architecture for that. So rest for NP hard, there is no clear-cut algorithm. We just see the most optimum results which we can get for that particular problem statement. So we don't say we write an algorithm as such for that. Of course, algorithm will be there, but only algorithm we cannot write the final solution. So your methodology, if you are solving an NP hard problem, it will have some framework or architecture. So it depends on the problem statement. So you should be clear about the methodology, what you are going to propose. Is it an algorithm, or is it a framework, or is it an architecture? That you should be able to visualize before starting the methodology. Now, coming to the results. So what are the basic things which you should have in the results? So first is, what are the experiments which you are going to conduct, and what is the setup for the same, and what is the data which you are going to conduct. Once you have all these things, contribution means you should talk about two things. Either or, both cases are fine. Either you can talk about effectiveness or efficiency, or you can talk about both. Effectiveness always talks about how robust it is, or performance metrics like how accurate it is, or tangible things like how cost effective it is. So all those comes under effectiveness. So how much robust or accurate the given problem, your methodology is for a given data set. The next aspect is efficiency. Efficiency always talks about either time or space. If your accuracy is same as a previous method or algorithm, but you are efficient, then it's a novel work. It may be time efficient, or it may be a space efficient. Coming to the data, in most of the problems which currently we are addressing, all are NP hard problems, because you know that for a rationale in the artificial intelligence, what are the things till Turing machine can write an algorithm? For that, the artificial intelligence can automatically write an algorithm. So there is no human intervention is required as such to write a algorithm for a problems of P class or NP class. So generally we don't solve a problem which is up to P class or NP class. It's already saturated. We generally take problems from NP complete or NP hard. So if you take that, then you should talk either about effectiveness or efficiency, because a robust methodology which is both effective and efficient is very difficult to get. So if you have some results for that, you can claim it. It's not a problem. But generally we talk either most of the time, not both. Now, what are the things which we should use, or what are the things which are expected in the results? So of course, graphs, figures, tables, all those things are required. Apart from that, you should be able to justify which one is better, why your work is better than the existing work, and you should substantially claim that. What do you mean by claim is, say for example, they might have done for 1 trillion or 1 million data, and you have done for only 10 size data, and you cannot claim that mine works better. So it should be substantiated that your work is very good. And when you do some results, when you run the program and search for the results, it always happens that you will get unexpected results than the expected results. So in such cases, it is very important to write the unexpected findings. It's very, very important. And if you have a O factor, you have to write that, because there are so many cases in which data visualization, you will find many such cases where actually you will not even thought that you will find that. So I will discuss few things while discussing the case study. Then superiority of the method. So if you have any such aspect once you complete, because your problem in the problem statement, you would have been defined about finding something specific. While finding that, if you find something else also, you can write that, and how robust it happens after that. That also you can write. That talks more about the superiority of the method. Next is don'ts. So you should never overstate the result. Whatever results you will get, you have to write that. If something doesn't work, you can write that it doesn't work, it will not work. If the research committee does not know that it will not work, then it is a good contribution itself. But you should never overwrite the result, because an expert will know. Say for example, you can proudly tell that from past 10 years I am studying or I studied 10th standard from past 10 years. So it's okay, you have exaggerated the things, but the expert will know that is a dumb result, right? So never overstate the result. Then again, limitations will be there for each and every paper, each and every published article, each and every project, because the limitations, sometimes you call it assumptions and all. So all the limitations you have to mention. It's mandatory. There is a difference between limitation and future work. I will just give an example. So this is emotion recognition. Okay. So here we are recognizing few basic emotions and other emotions. Now the future work is enhancing the capability of classification of these emotions or making it more robust. All those are future work. What is the limitation is we are not considering mixed emotions. For example, happily surprised. So it will get classified into either happy or surprised based on the probability distribution. So we cannot, but we can, a human can visualize what is happily surprised or angry or frustrated. So all those mixed emotion, it will not consider. So these are called limitations. So you should write a separate paragraph, or you should write a separate method, separate, what you call, justification you should have in your mind about the limitations of your work. Directly, I will go with the case study. So this is student engagement analysis. What you mean by student engagement is, am I audible? I don't know. Can anyone reply? Because I am just talking and talking. I cannot see the chart because my screen is full screen, so I will not be able to see the chart. Can anyone tell me whether I'm audible or not?
Yes, sir, you're audible.
Okay, thank you. Fine. Now this is case study. In the case study, I have taken student engagement analysis. What you mean by engagement is how much students are understanding within the academic learning time. What you mean by academic learning time is the time duration in which the student spends in the college, not in the hostel, in the college. That is academic learning time. Within that academic learning time, how much information is he gaining? He or she gaining. So that is student engagement analysis. How engaged are students in learning things? Now, student engagement can be done in various ways. There are the standard ways to analyze the student engagement is his cognitive behavior, that is what goes on in his brain, and his emotions and his behavior. So from these three also we can recognize the student's engagement. So the emotions, behavioral patterns and cognitions, all this combined we can tell as affective states. They call it affective states. With this basic introduction, I will just go ahead. See, literature survey, now you have found out very good papers from very good conference papers, very good journal papers, and you have taken some papers as a base paper and you have started your work. But your work is extremely novel, because in this case, what this paper does is it recognizes the student engagement I mean affective states, all the affective states required for the student engagement in the classroom environment. So this was not done before, though it was done. So there are few demerits which does not make it as classroom because it's like single person or e-learning or what you call social learning environment platforms. So if your work is extremely novel, then how to do the literature survey is you should take a paper, you should refer a paper. It can be from anything now, any indexing. For reference or citation, you can take from any indexing or any ranking papers. So now for referencing, you have to start from the beginning. So when it started, maybe it started in 1972 or 1998 or in 2010, when it started, from there to the current, how it progressed, that you should visualize. First, you should read all the papers, similar papers, because see, in a few cases, what happens is, I have seen my students doing that. So they see a few machine learning techniques which will not work, and they see some deep learning techniques which will not work. And in between, some machine learnings which are not used, they will tell that I'm using this, and they will claim that as a novelty, which is not correct. Because if you do the proper literature survey, you can make out that few techniques, machine learning techniques, are not sufficient. That's why they have moved to the deep learning. So like that, there will be a cases where you will understand the limitation of the methodology itself. So that's why it is required to read from the date started to the end. Not all papers, but you should get some idea about in between. You can search some year paper and you can see what's going on and all. So this sort of work, for this sort of work, this is a sample table which tells that what are the methods used and what are the merits and what they have used for the engagement and what are their limitations and what are the environment. There will be so many learning environments, e-learning, classroom, flipped classroom, and webinars. All those things comes under learning environments. So in which learning environment they have tested or used their work. So if it is extremely novel, then you should give the visualization or you should get the data, proper data for these things. What is the method and what is the area and what are the limitations and how I can map or apply to this particular area. If you are doing an incremental work, then how you have to do is, you should, incremental means generally they will have a standard data set established for this, or the data will be already available, or if you take the data also, the procedure will be already available. So since the data is fixed, the challenges will be generally fixed. The number of challenges with respect to data will be fixed. Hence, we are more focused on the efficiency or effectiveness here. So how much accurate it is or how much less time or space will it consume. So here the table or the information which you want to collect will be somewhat different. Here you will clearly say what is the data which the previous works have, which previous works did, and how many types of data they have collected, what are the data contents, and for that particular data, what is the accuracy or the performance metric which they have used. There are so many performance metrics for computer vision applications. We generally say accuracy, precision, recall, F1 score, area under the curve and all. So it depends on the domain. So if you are doing in smart city or IoT, then the performance metrics will change. So depending on the particular domain in your interested area, in computer networks, it will change. So you have to check only for that now. If you are doing incremental work, you should check for the performance metrics, basically the performance metrics, and what data they have used, and how best you can improve with your own proposed methodology to get the better results or enhance the existing system. So this is a sample screenshot which tells about the study of an incremental work. For my work, till then, there were so many results which are shown in the first table, where they use the pressure sensors on the stool. They will see the separate cameras for eyes, cameras for eye tracking. They will use so many things just to analyze the student's emotion. So these are called obtrusive. So here you can see the figure 1, which shows the subtle tone. What does it show is whenever you feel your class is bored, you have to click on that, the color changes. So these are called obtrusive. Obtrusive means you have to give a break, or you have to, your focus will deviate. So these are called obtrusive techniques. So we have to find a technique which is better than obtrusive, or which is not unobtrusive. We call it unobtrusive. So I came up with a solution, or one of the solution. So the problem statement goes like this: design and development of unobtrusive affective computing framework for student engagement analysis in classroom environment using deep learning technique. Now, if you see, as I defined earlier, so unobtrusive affective computing framework is the solution. So this part is the solution. And the problem here is student engagement analysis. So any reviewer, this will help actually to see an expert or your guide or your reviewer. So if you can write it properly, if you can visualize properly, you can write it properly. If you can write it properly, then by seeing just at the problem statement itself, they will understand whether it's null or not. Because unobtrusive techniques were very rare, even if it is there, it has a significant number of limitations. So people will know unobtrusive means there is some solution, it's a good solution, and it says framework. So framework means we are now solving an NP-hard problem now. So even for problems which are of P-class and P-class, framework can be written. But unobtrusive and affective computing framework means you are solving a computer vision based problem. That they will know, because only using non-verbal cues means hand gestures, body postures, with that we can analyze. And student engagement analysis is the problem here. Next, environment. So the domain is learning environment, and the subset of the domain is classroom environment. Why there is a difference in the problem statement when compared to the initial case study where I mentioned student engagement analysis in learning environments? So here the here the picture of feasibility comes. So whenever you do a project, after doing the literature survey, you should choose based on the time limit which you have. If it is an internship, then you have to narrow down too much and focus on only 2 months or 3 months which you get. If it is a project of 1 year project, then you have to see the feasibility, how much you can complete within 1 year. If it is a PhD work, then you have to see that you will finish within 3.5 years. So because you will be already wasting almost 1 year for literature survey and 1 semester for coursework and all. So you should see the feasibility first. So for me, doing in all 4 learning environments for unobtrusive analysis did not look feasible. So I had narrowed it down to classroom environment. And the techniques, as you can see, deep learning techniques is very vague and very broad. So generally the problem statement will keep a bit generalized. And coming to the objectives you can see it is a bit more narrowed down and a bit more precise. You can see multi-model students' behavior. In the engagement, I have narrowed it down to behavior. Directly I will go with the behavior. And multi-model, what do you mean by multi-model, I will tell. Considering various modalities is called multi-model. Say for example, if you are considering speech, voice, image, speech as voice, speech, image, and other sensor related data, and combining it, it's called multi-model, where you are getting data from different modes. This is one objective. Generally, it will have 2 to 5 objectives. I have shown an example, just one. And you can see the keyword to develop, which I have used in classroom environment. So objectives will be like this, a bit more precise when compared to the problem statement, and objectives always go with the problem statement. So if you combine all the objectives, you should get the result of all the objectives should be the result of your problem statement. You should make sure that your objective always serves the problem statement. Next, what and all things should be there in the methodology? This is the next one. There is something called flow diagram or block diagram, or you can say sometimes a flow chart. Everything you cannot represent in flow chart. So flow diagram is required. What does flow diagram do is, it will tell what are you doing in the entire project. It is not your proposed methodology. It's a flow diagram in the methodology. What is the difference between proposed methodology and flow diagram is, proposed methodology only talks about what you have proposed. And flow diagram always talks about the entire work which you are doing in this project. So every methodology should have a flow diagram. And flow diagram should be very simple. A layman should understand. So here you can see this is a classroom environment. We are taking data from the CCTV camera or the web camera or any camera which is fixed. all the students should be covered in that camera. And since we are using learning techniques, that is machine learning or deep learning, so training and it has a classification. So if you don't understand, don't worry much. So this is a labeling. We have to label the data and we have to train it. Once the label data is trained, we will test it because it will be trained based on the ground truth. That label data acts as a ground truth. From that, we will analyze. This is how the machine learning or the deep learning works. Now, we will take the data. In order to train, we have to annotate. Sorry. In order to train, we have to annotate. So this is the annotation module, that's indirectly the training module. Here actually we'll take the video, we'll take each frames and we will give some class labels. This is behavior. So there are 4 different class labels, standard class labels for that. And from the same source itself or the same classroom environment itself, we will take some other data and we'll check. So if your data is only from one source, then you have to do some validations like 10-fold cross validation and all. I will not go into technical details much. So what does this figure depicts is you will have a training module and you will have a testing module. This testing module is the classification module. Here you will take the Fourier frames, then you will apply some method and it will get classified. Once it gets classified, you will have students, each student's behavior pattern and also the entire classroom's behavior pattern. That you will do a survey of pre-test and post-test analysis, and you will compare whether there is any correlation or not. So these correlation tests, all those things comes under statistical analysis, and you will do the statistical analysis. This is the first objective's entire workflow. So if it is a PhD, then for each objective you can get a workflow, but for a BTech project or internship, one workflow per project is sufficient. Now, once you have a flow diagram, then what are you proposing? So that is important. If you can write an algorithm, fine and good, you can write an algorithm and you have to show the time complexity and space complexity, and you can give the proof of correctness for that. So if you cannot write an algorithm, then you can give an architecture. So these are the deep learning architecture. Now, if you are using already existing deep learning architecture like this, if you are using already existing deep learning architecture, you can cite the existing one and you can proceed. If you are proposing your own, this part actually here, this is a proposed one. So if you are proposing your own architecture, then you need to give all the justification stating that this is good and robust. For that, how we should give is, we generally use mathematical model. We give plenty of equation. If it is in a very standard architecture, it will go around 20 to 25 equations where we will clearly say how this model works exactly for what values and what are the possible values which will come, what are the outlier values. So everything we will write, how it behaves for everything, that we have to prove mathematically. So mathematical modeling is required if your methodology contains novel architectures or algorithms. If it is not the case, then you can cite the paper where it is, where you have taken from, and then you can use. See, you can use all the existing state-of-the-art methods, applications, or techniques, and still you can do a very good project. As I said, if you are doing it in an unused domain, then it's a novelty itself. There you will be using a methodology which is already there. That is also fine. So I'm just telling about the architecture where you have proposed. If you have proposed, then these things are mandatory. Just simply claiming that this is a very good algorithm doesn't serve the purpose. You have to give some proof of concept or modeling. Next, when you start a project, you are trying to address some issue. There is a difference between issue and challenge. So while addressing the issue, you will get some challenges. So these, say for example, in my work, facial recognition for affective state or the emotion detection was very popular, and many people claim that if you recognize only face, then it's more than sufficient and all. So based on the literature survey we have done, since it was not done in the classroom, so we are unable to know the challenges what we might face. So the point is here, you can see the difference. See here, it is sleepy and happy. See the next image. From face, you can make it out easily. It is happy face and this is sleepy face. But when you consider the entire body or the upper body, then you can easily make out that this particular affective state or emotion is confused and he is actually engaged, not sleeping. So these are the various challenges you will get. So once you get some point where you get some challenges like this, again you have to go back and search what are the best things, how they have addressed this sort of situation and all. And one of the solution for this is I got to know is using the bounding box. What do you mean by bounding box is you will put a box like this for the entire body or the entire student visible, and then all the data within that box, whatever you get, that is used for the classification. Again, we had a problem for that. Here the problem is that this guy is engaged. He is answering some question or attendance or something. So if I train this as answering attendance, then the problem with that is this background data will also be used for training. That is wrong. In a more serious case, see here, this student is actually engaged with something, but the data in the background where she is sleeping is also getting trained in the deep learning model as engaged. So which is wrong. So using optimal bounding boxes for the student is again one more challenge. So while doing the project, research-based project, you will come across various challenges. Again, you have to go back and search what are the best possible solutions which they did and what you are going to propose. Next thing is database. So if you already have a database, then you just use the database. You take the most robust database or the database which contains various varieties that you will take and you will do. That is fine. I'm just talking about the scenario where you have to create your own database because it's extremely novel. So in that case, what you have to do? So this is one such example where we created a data set with the students in classroom environment. As I said earlier, there are two types of data we can select. One, we can tell the students to pose a particular emotion or affective state. That is called post. If you are posed, then is a standard practice to ask general health questionnaire. We have to check his stress. So when he's stressed, all the expression will look the same. So we have to do the testing survey before that, and then we have to allow them to give her this one, post expression. If it is a spontaneous expression, then you just keep the CCTV on and collect the data and annotate. But simply doing that, will it serve the purpose? No. So this table talks about emotion, this table talks about behavioral pattern. Initially, we started with just 3. We got better results, and then we shifted to the all dominant learning centered emotions. Once we got the emotions, we shifted to the behavioral patterns. Once we had both emotions and behaviors, then we moved to the actual student engagement analysis. But before going to that, just getting the data and annotating is not so simple. Why? Because for everything you have to follow the standard practice. The standard practice is that you have to take average of few people in the annotation. Say for example, if somebody is telling he is engaged and the other guy is telling sleepy, then it's not correct, right? So we have to take a definite method where it tells this particular image belongs to this particular affective state. For that, there are various standards. One of the standards which we have used is gold standard study, where 3 different annotators annotate. So one is the student itself, another one is novice who doesn't belong to the education or learning environment, another one is an expert who is a faculty or a PhD guy who is well known with the annotation standards. What you mean by annotation standards is for emotions we have definitions. For each definition, what action units and what are the facial expressions which should come. So that will be defined as a standard. The one who is aware of that is called an expert annotator. So we should take all the 3 and we have to see the average of them. Again, how to see the average? There is a statistical analysis for that. Cohen's-Kappa talks about the reliability. If the reliability is extremely low, then those images should be discarded because it will confuse the deep learning architecture. Because one might be telling engaged, the other might be telling sleepy, so which is dangerous for the model. Again, you have to do and store the data. So all this, and we have taken data from various cameras, web cameras, CCTV and all, that to show the robustness of the data, that's all. But the most important thing about the database creation is, if you are involving either human subject or any living subjects, you should get an approval from ethics committee. So if it is a human subjects, then Institute Ethics Committee or the regional ethics committee is sufficient. If it is a living organism other than human being, then you need to go with the procedure. You have to take from 4 to 5 different bodies, governing bodies, to make it a data, annotatable data, and which can be shared as a standard data set with the global at the global level. So ethics statement is the one thing which you should remember if you are creating your own data. Just collecting the data and simply hosting it as a standard data set after doing so many analysis without ethical statement is also wrong. They will immediately remove the data from that particular standard websites like Dataport or Kaggle or something. So those are the website which contains our databases. They host the databases. So they will not allow unless there is an ethical clearance for the data. That you should remember if you are creating your own data. Next, coming to the results part. How to show the results. So if you can, mine is computer vision based work. So I can show different images and I can convey how it is better. It is not possible in all the cases. So there are various ways to show. So in computer vision, you can see these are the results where actually even the students who are on the last benches and whose head is down, all those images whose face is tilted, all those are selected or what you call recognized in this proposed algorithm. But in the existing algorithm, they were missed. So there is an improvement in this proposed method. So if you can visually show like this, it's fine. Or else there are various ways. Anyhow, I'm going to discuss that. Now, if you have a confusion matrix, you can show it with a statistical, this is heat map. You can show it in a heat map. If it is a statistical analysis, you can show using dot plots. If it is still more, you can show it using mean or standard deviation. Still, you want to show how the diversify or the variance, distribution of variance and all. You can use box plot like this. So you can clearly show the outliers, where the outliers are, and how the data is distributed against each class level, so that how the database is clearly distributed. That you can show using box plots. Next comes is, as I said earlier, so efficiency and effectiveness. So that you need to show. If you have already an existing method, you can compare. So time in seconds talks about the efficiency and accuracy talks about the effectiveness. You can have multiple axis charts and you can show in a single graph itself. There are other graphs like pi and all. You can use line graphs, you can use transition graphs, you can use spider chart. The best suited for your results you have to pick and you have to show. By just seeing at the image itself, it should be clear what is the contribution of your proposed method. So you have to choose the visualization in such a way. Now coming to the tables. See, in results, if it is an incremental work, then you have to show all the existing methods. These are the existing methods. What are the results? And what is the best possible performance metrics? Here, MAP is sufficient, mean average precision is sufficient. If not, then you have to give all the performance evaluation metrics such as accuracy, precision, recall, F1 score, and you have to compare with the proposed methodology, and you should give a proper comparison table for the available dataset or the created dataset. It shows how robust it is based on the database, and this talks about accuracy. And one more is cost effective, which I said. So what is the cost of your work and how much you have used? What is the cost of the existing tools, if it is available? So that talks about effectiveness. Next is efficiency, time and space. So if you are using an IoT application, then you should show end-to-end delay, how much time it takes, how much delay is there. So all those things you have to show using proper visualization charts. So, but you should always talk about either efficiency or effectiveness, which is very much required. Without explaining any efficiency or effectiveness, it is not considered as a research-based project with contribution. Next is that you have seen for incremental-based work. Now you have to see for novel work. If it is a novel work, what is the best possible results you can get for which methodology? If it is proposed, if it will be proposed, or what is the state-of-the-art method which is giving better result, that you have to give in detail. And if you have done any statistical analysis, if it is the database, then you should give a statistical analysis. Without that, we will not be able to know that you have enough variance or the robustness in the particular database. But one more thing you should remember while creating your own data is you should benchmark the data. What do you mean by benchmark? you should see what is the basic algorithm which is designed. This may be LBP in 1972 or 1978. From there to till today, what are the most standard methods which are still in use? For all those methods, you have to give the performance evaluation metrics for the entire database. This is called benchmarking. So if you are creating your own data, then you have to benchmark. Just benchmarking itself is a standard and very valid and popular project. So you can see so many publications in that where actually they just benchmark a data. They just create a data and benchmark it. Even I have papers where they have just annotated the data with proper statistical analysis. They have proved that the annotation is reliable. Even that is a very good contribution. The next thing which your results should have is how best your model is. That will come with overall discussion. There should be one overall discussion with your project. It's mandatory. Your result section should have this, or else it will be unclear whether your contribution is good or not. Say for example, in this particular scenario, here the proposed method is actually, as you can see, it has various variants which are mentioned here. Few papers from this is the start, student engagement in classroom. It started here and till 2019. Even this paper got published in 2019. From start to till date, all the papers, popular papers, are actually referred here. And what they are doing, these are the various parameters which are considered in their work, and this is the parameter which is considered in the current work. Here you can see multiple phases are not used in many. So there is a one contribution here. One more contribution is engagement analysis, which nobody has done, group engagement, which is one more contribution. And as you can see the data, so during that time the data was not so freely available. So nowadays we have plenty of data. We have various sources to collect the data. So we have the data in bigger size. And one more thing you should observe here is the accuracy or the performance evaluation is the area under curve. This is actually only 70% for the proposed methodology. You have something which is more than that, 85%, 79%, 81%. So you should not play with the results. Whatever you got, you can mention. Here they have used something called KINECT. So KINECT has a demerit. If it is a long or a big classroom of 60 students, only first 7 to 8 students will be recognized in KINECT. KINECT has a significant demerit. So you need not worry about that. If your work is proper, work has a proper novelty, then you need not worry about the accuracy. If it is novel based, then any accuracy you get will be good, because since it is novel, so you can easily prove the limitation of other works. This is one thing you should remember. Next is, what is O factor? We found out that there is a transition graph. When we analyze the students' engagement, we found a transition graph. It's evident, like somebody is engaged, suddenly he will not go to sleep. It is very clear, right? So people will not be bad. So there is a pattern from engaged to sleep. The people in the class who is sitting very engaged in the first 10 minutes, he goes to sleep, means there is a pattern. That pattern we got. What is that is, it's a generalized pattern. Generally people may not, all the people will not get that, but most of them got this. This pattern we got. What is this? It talks about engaged to confused, confused to frustrated, frustrated to bored, and bored to sleepy. Bored to sleepy will be always in concentration. Why? Because if the faculty sees him, he will just open his eyes, or he will just see the board or something. Then again he will go to sleep. So this is a pattern which we got through the statistical analysis. Even though we know, unobtrusively analyzing these patterns is actually contribution. Now, one more, the superiority of the work is, we did not consider any scenarios where actually it should detect for blur images and all. Anyhow, camera will be good. For that camera image itself, it should do. That was the main intention or the objective based on the problem statement. But our work also, proposed method also worked for the cases where actually it is a blurred. Here, see, this guy's face is blurred. Still, it detects the person and also tells which behavioral pattern he is in. So this is the superiority of work. If any such O factor or superiority work is there in your work, that you can mention. If it is not there, then it's fine. If it is there, you have to mention. It is not a demerit to mention a good thing. Now, I will just show you a demo. This is the engagement analysis in the laboratory from the proposed method, which I have done, how it works. I will just play the video. Yeah, I hope you people saw the video. Video was not lagging or something. Can anybody tell that? Did you see the entire video with the same flow?
Yes, sir.
Huh. So you can see here in the video. So it clearly recognizes this guy's discussion, and suddenly he puts his hand near the mouth and he yawns. So that is, with that time fraction also, it is considered as sleeping. So the algorithm is actually very good. But if the algorithm is giving 100% accuracy, then you need to check, because overfitting might happen. That is more technical. I will not go into that. But so if it is a novel work, then it has various other significance also. Now this is the end of the first case study. Now I will summarize once again, because methodology and results I have given the detail in clear. I mean, the details more clearly, but I missed the literature survey part. Now you can easily map. So once you choose the topic or domain, then the next step is doing the literature survey. So maybe the topic is like you are analyzing, or there is an auto tutor you want to prepare for Bharatanatyam. So which just sees the video of a dancer and tells whether he or she is doing the mudras or adus or dance steps, postures correctly or not. So that is your interest, let us say. If that is your interest, then you will do literature survey and check whether people have done this or not. So once you do the literature survey, then you will understand that speech is not of significance to analyze the data. So video analysis is not required, only image frame based analysis is required. This is narrowed down of the topic. Then you will go to the problem statement. In the problem statement, the initial problem statement is just analyzing through the images, the mudras and all those things, postures and adus and all. Now you will see whether there is any existing method which is similar, I mean, which is there for similar sort of work. Say, for example, a tennis player hitting the shot, whether it is in the perfect posture or not, there is a paper. So you can map to such works and see and apply those methods to here. So that you will do. So based on that, you will fine tune the problem statement. So see here, say for example, if there are more than one people in a frame, then it will be difficult. So what you will do is, for single student or a person, the auto tutor of Bharatanatyam can be one example of fine tuning the problem statement. Once you fine tune the statement, then you will define the objectives. If you have the objectives and you have done already the literature survey and methodology, you will proceed with the methodology. Now, while doing the methodology, you will definitely face some challenges. So once you have the challenges, again, you have to go back and check which particular solution best suits it. So what they have used in the literature, how you can overcome this. If you get some results which are unexpected but still promising, then again you have to see how to represent that. If required, you have to do the literature survey again. So literature survey comes in so many times during a project, but most extensive literature survey as such you will do only 2 times. One is to narrow down the topic, another one is to narrow down the problem statement or fine tune the problem statement. So rest will be of just as a reference, you will go and check and you will do. But these 2 are mandatory and is a primary requirement for any research based project. Now case study 2. Already it's 4:12. Ma'am, can I take 10-15 minutes more?
Yes, Ashwin, please. You can continue.
Now in the case study 2, since I heard that so many people are interested in application-based projects also require some sort of research. Without doing background study, you cannot do. there is no point in reinventing the wheel. Say, for example, I will prepare an application which stores the image in the gallery. What fun is there in that, right? So there is some background work is required even in the application-based research project. So I have done plenty of research-based project, I mean application-based projects. So I will show you the tools or the hardwares or the applications which are already available for the different state-of-the-art tools for different domains such as augmented reality, virtual reality, and Internet of Things. Because I found out that these three are the major areas in which, apart from blockchain and others, people are looking at in the application-based project. So I can show you a few videos. The first one is Google Glass. If you already heard of it and you already saw it, then it's fine. Or else you can
Here are the basics
just see
of
it.
how to use Glass. This is your touchpad. It runs from your temple to your ear. Tap the touchpad to wake up Glass. You should see the display above your line of sight. Adjust it to see everything. The home screen shows a clock. This is your timeline. It's a row of cards. Things to the left are happening now or coming up, like the weather, an upcoming flight, or an event in your calendar. You can tap on any card to see more. Swipe down anywhere to go back to the timeline. Cards to the right of the home screen are from the past. For example, messages, videos, or photos. Tap on a photo to share it and choose one of your friends. Swipe down to go back to standby. And have fun exploring.
This is one tool, Google Glass, that is augmented reality, as you can see, where we are augmenting the what you call. There is a augmenting device which augments with the reality, and the output is in both reality and in the virtual environment. That is augmented reality. This application is purely again augmented reality based, but it's purely based on the human activity recognition.
So, you've come back for more, Ian.
Yep, let's do it.
This should be good. Let's begin.
The tires are toast.
Alright, I'm going in.
Okay, I'm ready. I can tell you something, David. You can't recreate a finale like we've seen in this chapter. She sets it up.
Yes, I did not show the complete video, but you got the idea, right? So it has the whole body tracking, the skeletal system, voice-based input device, input system, calibration, and multiple person in the frame and controller. So this example video which I have shown is Xbox, which is for the gaming purpose. But if you are planning to do the research, then there is something called Microsoft KINECT, which is same. This is Microsoft Xbox One. Microsoft KINECT also has the same functionality, but still it is more enhanced. In fact, it can recognize up to 6 or 7 people. So you can use such tools and you can design the application-based project. One more is Leap Motion. This just recognizes the hand gestures and you can use it for any hand gesture based application. So this works on the infrared rays and the visible light. With that, it will take the input, and without using mouse or other keyboard, you can still give the input. So this is one of the virtual augmented reality tool. And Oculus Rift, it's a virtual reality tool where it is a head-mounted device. So I will just show you if it is very. Yeah, he can be in the virtual world like this. This will be a virtual world, but this will be there in his helmet. That's all. So this is one of the tools for virtual reality. And Sense 3D is again augmented reality. So here you can yeah, this is a tool actually which is used to take the object in 3D mode. So you can take the details in the 3D environment, you can print it or use it. Initially, it started for archaeological purposes, where actually old monuments and all used to get scanned, and they used to take print and then do the analysis and all. So you can use for any real-time application. Then it is Mayo. Mayo works on the signals. So it's a sensor-based one where actually it takes muzzle impulses as a signal. I will just show you the video. So as you can see, the Mayo is used in various different environments, and it's also an augmented reality based tool. Then there are a few others like Fin, which is which acts as a ring. So using that ring, you can
which are tiring and boring
do the day-to-day activity.
You control any smart device just by moving your thumb over other fingers. Isn't that super simple and super fast? After a year of research and numerous experiments, we made this perfectly working prototype. However, we don't want Fin to be just another geeky device. We want people to wear it as a fashion accessory. Fin is a Bluetooth-enabled device which can control a variety of smart devices. For switching the device to another, all you need to do is tap on your finger. Fin makes life simpler. Now, everything is at your fingertips, and it feels like having magical powers.
So they started this Fin by thinking that this particular device can be used for as an input device or a remote for multiple devices in the smart environment. So similarly, there are various tools which are state of the art, which are available. I did not added all the videos. These are the tools on which I have worked on, and we have published so many papers in that. On KINECT, these papers are on KINECT, where we have used KINECT for various other activities like security, for analysis of the mood, and for using it as an education tool to improve the handwriting of a kid who is 12 or 10 years, below 10 years of age. And I have more than 25 conference papers and 5 book chapters on these tools and devices. Here we have used Arduino to assist the visually impaired, where it will tell if you keep it any incoming vehicle with what speed, and whether it is a pit hole, a pothole is there, it will detect that. So we have done various works using these tools also. And our HOD is also planning to buy a few tools. If you're interested, actually the ones which are available in India, you may get, and you will be able to do some projects on this also. Now, what is the one important thing which generally people miss in the application-based project? Anyhow, they will tell about the results which are already there. That is true about the efficient and effectiveness and how best the particular product or application is and all. But every application-based project should have these three things: useful, usable, and used. Useful is, it should be useful for the particular task which you have designed for, and usable means it should not cause harm, and also it should be usable for all category of people. If you are designing for a if you are not specifying for one particular category, it is for general use, then you should be able to design it for all category: age, old women, handicapped, physically handicapped, deaf and dumb. So you should consider the usable part also. Then what is used is, any application means people should want to use it again and again. So these three should be there. I will not go into technical details for that, because we have to use Senderman's criteria and Norman's principle for doing any application-based project. That is a mandatory stuff. But in results, you should have results at least which should tell about these three factors. Using the basic type of analysis of results of application-based project is Likert analysis. So this is one of the basic. At least you should do Likert analysis if you are doing any application-based project like web design, Android app, or any hardware tool which does some specific task. You should be able to do minimum a Likert analysis. So if you still go beyond that, then you can do some other analysis also, and you can put the box plot and all. And one more thing you should do is, any application-based project, you should give testing with you should test with some users, and the users will give the feedback, right? You should take the feedback and you should mention the feedback. Feedback is as important as the result, as the efficiency and effectiveness results in the application-based project. This one should not forget. Now coming to the tail end of the talk. So what you want to do for any project, how to choose a topic. I personally suggest in solving any real life problem in the locality, which help the people around us, not just globally. And also, there are so many areas which are not explored in the interdisciplinary. Say, for example, these three images I have already put in the initial slides. As you can see, so you may be interested in football, you may be interested in cricket, you may be interested in any other extracurriculum or co-curriculum, you may be interested in singing, all those things. So you can still do the project, wonderful projects, like, say, for example, a tutor for basketball or a hockey or a football, how you're standing, how your stance is, whether you're hitting with the right amount of speed or not. So all those things are actually very helpful. You cannot get a personal assistant for everything. For everything all the time, right? So you should be having a proper. Say, for example, if you are a novice player and you are not so interested in playing cricket, it's just an hobby, then nobody is there to teach you. So why can't you have a personal tutor which can teach that? Not just that, even if you are interested in cricket, you can use some sensor to tell whether the batsman is not run out or not, by just seeing whether his bat is inside the line or not. Nowadays they just see the image, right? So which is not so easy also. Sometimes there are ambiguities on the line and all, how to address that. You can use sensors and you can solve those issues. Similarly, if you are singing, a singing assistant you can make. There are so many things which you are interested in extracurriculum that can be brought back to the project. We using these techniques like image processing, pattern recognition, grid computing, cloud computing. These grid computing, cloud computing and all we can use to make an IoT device where in edge it will make the decision and it will find the answer. So not just doing the core work of what you call basic subjects, you can also do the interdisciplinary work as a project, which is also a very good work. So you can try doing that. Thank you so much. I hope you got some insight about the research-based projects. And if you have any questions, please ask. Thank you.
Yes, if anybody has any questions, you can ask now. You can unmute yourself and you can ask. Or you can even type the question in the chat box. I think there are no questions, Ashwin.
Yeah, that means either they got something or they did not get anything. That's fine.
No, I think
They can ask me anytime.
students,
They can mail me.
yeah,
They can text me. It's not an issue.
yeah. Okay. Thank you, Dr. Ashwin. It was indeed a very nice experience, a nice walkthrough to how to carry out research-based as well as application-based projects. You have very well explained how to define a problem statements and how to derive the objectives from the problem statements. What are the keywords the objective should have? What, how to put the flow diagram in the methodology, and how should the results be compared? What do you mean by benchmarking? You have indeed explained it very well. I hope it will be very useful not only to students who want to do research-based projects, but as well as faculty who are trying to pursue their research. You also very nicely explained how search for a good conference and journal. What do we mean by core conference and so on. So I hope with this information our students and faculty will be able to take up the research initiative. You have laid a nice foundation. Usually what happens is when we start our work, we will not be having any knowledge. But I think this has given a very nice input to everyone here. I thank you very much for the efforts you have put in. Thank you,
Pleasure.
Dr. Ashwin.
Yeah.
Thank you very
Thank you,
much.
ma'am. Thank you.
Yeah. Shall we sign out as there are no questions? Students or faculty, if you have any questions, you can ask.
Okay, ma'am. I will.
Okay, Ashwin.
Yeah.
Yeah. Thank you. Thank you very much.